Greetings, everyone. This is Jyoti Dodia, and welcome to the 114th session in the Power Virtual User Group Technical Webinar Series. Very pleased to have Jesse Gorzinski with us to come back and talk about IBM I open source solutions and what is new in that area. But before handing over to Jesse, let me just tell you a little bit about some of the upcoming events. So the first one I wanted to mention is there's a few webcasts coming along in May, run by Common and IBM, the May the 3rd, 4th and 5th. And the details for these sessions will be in my replay email, so do watch out. After the replay information, I will highlight some of these. So we've got Steve Will and Steve Sibley on the first one. We've got Carol Woodbury talking about security, and we've also got Philippe in ARCAD and Steve Will on the third one. So these will be highlighting some new and exciting things coming down the line. The second set of events, or second event, I should say, that I'd like to mention is the 12th of May. If you're in or around London or in the UK, please come along to an event organized by Tech Data and IBM. It's the IBM Power Spring Announcement event in IBM's brand new facilities in London called York Road. So I hope you can join us then. And then on the 7th and 8th of June, we have the International iPower event. These are all IBM I focused events. There'll be some power elements too, and also some AIX in some of the events, but these are face-to-face. The previous one and this one is face-to-face. This one running in Northampton in the UK. And then I would like to hand over to Ranga Deshpande, who's the President of Common Europe, to just take a couple of minutes to talk about the Common Europe Congress that is happening in June. Over to you, Ranga.
Thank you so much, Jyoti, for giving me this occasion. And Jesse, thanks for accepting it. So guys, you see this big diamond here? That diamond represents the 60th anniversary because Common Europe started in 1962. So we are going to do a big pomp and show anniversary celebration in Alicante, and Alicante, Spain. And why? It is 13th to 16th of June, and that will be an in-person event, in-person congress happening, and this is the largest gathering of power systems and IBM I community members there. So you are all invited, and I'm just going to give you 5 messages. So the first message is don't miss 13 to 16 June in Alicante. There we have the Congress, the Expo, and the 60th anniversary. The second message, I will not go through all this, but most important, second message, on day 1, that is 13th of June, we have 8 in-depth 3-hour workshops, and they will be in the morning, 4 in the morning and 4 in the afternoon. So you can attend 2 of them, and they will be on application development, open source, system management, and security. Then second message, third message, it is on day 2 and day 4, we will have 102 sessions, and they will be roundtable also, and there again will be all that you need to learn, and you need to update your skills for the coming year, and all the announcements. And we have speakers from all over the world, all IBM experts, the Rochester business architects will be there, and then we have industry experts. And on the same day, we have the IT Managers Day, 14th of June. On day 2, we will have again the sessions and ISV Day on day 3. And on day 4, that continues. And it doesn't stop there. My fourth message, during all this, we will have real social events for extensive networking and fun. And don't forget that on the day 3 evening, we have a big 60th anniversary celebration. It will be a party with fireworks. So don't miss that. And the fifth message, next slide, please. And the fifth message is very simple. You are all invited. And to give you an incentive, all of you who will be writing in the registrations Power VUG as a sponsor, you will get early bird member price, and that is 625 euros. And with that, you have everything I told except the workshop, that is extra fees. So the full information is on Common Europe website, 3xw.comeur.org, and my email address ranga@comeur.org. So guys, see you all in Alicante. Thank you, Jyoti. Thank you, Josie.
Thank you very much, Ranga. So hopefully you'll be able to join one of those sessions. So here we go. Without any more further ado, let me hand over to Jessie in a moment. Just bear with me.
All right.
Okay.
And while we're getting things handed over, I'll briefly introduce myself. I know some of you have already crossed paths with me, may know who I am. For those of you who don't, just a brief intro. I work at IBM as business architect in charge of open source technologies on IBM I. My day-to-day role is essentially doing anything that I can to help customers succeed in using open source, which might mean orchestrating some of our support offerings. It might be hacking away at code. It might be doing some presentations such as this today. And that being said, it's an absolute honor to be here for this event. Absolute honor to be speaking to a very international audience, people attending from around the world, multiple countries, multiple continents. So it's absolutely an honor to be here. The topic today is really focused on open source and integration in general. Arguably more about integration than open source today, because customers are loving open source. They're loving all the amazing things they can do with the platform these days. But still, integrating IBM I with various technologies is a hot topic, will continue to be a very important topic for our clients. So we're going to start out today with a little bit of a brain teaser. I'm going to ask you a question. I'm going to show you 3 slides. They'll have something in common. If we were in a room together, I would say, hey, shout it out when you know it, but you will get it pretty quickly. But see if you can figure out what these 3 things have in common. Number 1 is El Chupacabra. So it's familiar. It's a Native American folklore animal from the US. There's a magical unicorn. And of course, a fully homogeneous enterprise landscape. You're probably figuring out these things. What they all have in common is that none of those things really exist in real life, as we know. If all of our IT infrastructure was all homogeneous, same technologies, same operating system, same database, that would make our lives a lot easier. Right? I mean, it would just, things would go smoothly all the time, right? And that would be an IT person's dream, perhaps, is to be able to say, yep, I'm using the same database, the same front-end languages everywhere. But we, of course, know that that's not the case, right? And with each passing day, it becomes more mixed, more heterogeneous, more and more distinct and unique technologies need to be wired together to build solutions that last, to build solutions that meet business requirements, or to build solutions that are the best in their industry. So our enterprise landscape continues to become more and more complex, which is why integration is a key aspect of any IT person's job these days. Even somebody who's a full-time back-end developer or front-end developer, there's always this element of, architecting integration between various systems. Right, so the topics today, I'm going to talk about a few of my favorites, in particular favorite technologies that people have been using to integrate IBM I with the rest of the world. Apache Kafka, Apache Camel, the new HTTP functions in DB2. I'm going to talk very briefly about a few other solutions as well. But I do also want to say, as I'm talking, I have a lot of content today. I tend to speak somewhat quickly. I'll try to slow down to a normal person's pace, but this stuff excites me. But feel free, as I'm presenting, drop any questions you have in the chat. I am able to monitor the chat as I'm presenting as well. So feel free to drop any questions in the chat as I'm presenting. I'll probably stop a couple times to ask if there's questions as well. So let's get started with Apache Kafka. Kafka is, in my role, one of the hottest technologies in the IBM I space. And maybe, in the next 15 minutes or so, you will understand why. There's not a week that goes by that I'm not talking about Kafka to somebody who's interested in Kafka, to somebody whose organization is deploying Kafka, has deployed Kafka, or integrating with Kafka, and so on. It's a very hot technology in the IBM I space. Right. And to understand why, you have to understand some of the messaging, or some of the history behind these messaging applications. Right. Back when the industry started to realize that the IT infrastructure was very mixed, that there were all of these different technologies that needed to talk to each other, it kind of birthed this idea of enterprise messaging, which is you can have completely different technologies, but if they can talk to each other in some kind of message that both of them understand, you can start federating these different technologies very easily. Right. And over time, there was also this pattern that arose of enterprise service buses, or ESBs. And there's some very, very good commercial ESBs, as well as there's open source ESBs as well. But these ESBs would provide all of these different functions for federating different technologies in your infrastructure. But the key piece here has really been that messaging component. And that's where this notion of message-oriented middleware comes into play. Oftentimes companies don't necessarily need a full ESB that does all of those things listed on the previous slide, but they do need some kind of message-oriented middleware to mediate the messages between the different parts of their infrastructure, right? And there's commercial versions that have been around for a while. Amazon, Oracle, IBM, they all have, Red Hat even now has these commercial offerings that provide this message-oriented middleware. But there are some really, really good, really tried and true free, and I say free in quotes because we all know, hopefully, that open source isn't free. It does have some overhead with keeping things current and maybe getting support and things like that. But there are some really good open source solutions in this message-oriented middleware space, right? ActiveMQ is a traditional messaging implementation, supports a good number of protocols, including protocols for driving Internet of Things and cool stuff like that. Don't have time today to talk too much about ActiveMQ. I will be focusing on the others. Camel, which is more of an integration framework. We'll cover that later on quite a bit. But Apache Kafka is, again, one of the hottest technologies now because it's really based around this idea of being distributed in nature, being able to handle large amounts of data and to do so very reliably, right? And actually, if you look at some of the design decisions behind the, the birth of Kafka, if you will, and surrounding technologies, Zookeeper is kind of the underlying distributed computing framework that Kafka is built on. But if you look at the design patterns that these were built to enable, it's data federation, it's edge computing, it's doing distributed computing and large data. And these are now the core tenets of hybrid multi-cloud. And we all know that hybrid multi-cloud is becoming very quickly the standard mode of operation. Everybody's doing hybrid multi-cloud. In fact, this is a study from a couple years ago where they said they predicted 98% of organizations will use multiple hybrid cloud environments by 2021. Different studies have different numbers, but we know by now, it's 2022, hybrid cloud is virtually everywhere, right? In the sense people have some components that are running in Azure, or AWS, or IBM Power VS, and they're integrating that with their solutions. What's interesting here is that as they interviewed executives and CIOs and IT managers about their concerns when talking about hybrid cloud, their concerns are really interesting. Movement between the clouds, connectivity between the clouds, right? How do you manage all of this data that needs to be shuffled around and communicated between all of these various pieces of your infrastructure? Some might be on-prem, some might be in a private cloud, some might be in a public cloud, and just being able to federate all of that has been and continues to be a top concern as hybrid cloud becomes the new normal. Right. Now, Kafka fits this bill really well because Kafka is this message-oriented middleware that is very easily distributed across multiple systems. And so you can actually have a Kafka cluster that exists as kind of this singular unit in a public cloud, geographically distributed, and on-prem, even on IBM I, everything in between. And so for this reason, there are some key industries that have been adopting Kafka like mad, especially the larger companies in these industries, right? So this isn't an average of all of the companies in these industries. This is analysis of the 10 largest companies in these sectors, right? So eight of the 10 largest telecom companies are using Kafka. 10 out of the 10 largest insurance companies using Kafka. 10 out of 10 for manufacturing. You see some more silos on the right. Retail, manufacturing, right? What's interesting about these industries, these silos, is that these are exactly the same industries you would talk about if somebody asked you about the prevalence of IBM I in the ecosystem, right? We would talk about the insurance companies, we'd talk about the banks, we'd talk about manufacturing, we'd talk about transportation, right? And that's why right now integrating IBM I with Kafka is a very important topic. Right? It's also important to understand why Kafka is a little bit different from some of the traditional message queuing that you may have seen with some of those commercial offerings or ActiveMQ, right? Traditional message queuing means that there's somebody putting messages on a queue, and much like a data queue on IBM I, other people are pulling these messages off one at a time, doing something with it. It's great for mixing various different technologies, but it doesn't scale as well as the Kafka approach. Kafka approach says I'm going to take, when somebody writes data to Kafka, Kafka, again, can be automatically distributed, so you can have that data automatically existing in multiple places. Again, geographically distributed parts of your cloud, different components of your on-prem infrastructure, and you can have multiple consumers consuming from different parts of it, which means it scales very well. And also, it's built on this notion that it can stream large hunks of data to you. So if you want to know all of the activity that happened since yesterday at 2 o'clock, you can get all of that information streamed to you in one nice stream of data, and it's much more efficient than the traditional message queuing, right? Again, a key value proposition of Kafka is this distributed property, which is called partitions in the Kafka world, right? And again, this notion that you can write data, have it exist in all these various places because Kafka handles that for you using its underlying distributed computing framework, and that you can have consumers listening and consuming data from these topics from all these different places means it scales very well. You can achieve horizontal scale with Kafka very well, which is, again, what we need in a global hybrid cloud type of scenario. Now, if you want to actually obtain Kafka itself, the Kafka broker or server, if you will, or any of the Kafka clients, there's information about how to do that from the Kafka Apache website. You can go out there and explore. Key point here is that not all open source comes in the form of RPMs, right? For those familiar with the open source ecosystem on IBM, you probably heard somebody talk about, hey, IBM has provided hundreds of RPMs and you download them with these tools and ACS and so on. And there's some really great stuff in there, but that's not everything. The amount of technologies that IBM has invested in goes well beyond those few hundred packages even that you get in RPMs. We worked with Apache to bring Kafka to the platform, and it's all available through, in this case, the Apache Software Foundation. Now, I've been talking about Kafka for a good bit, but I do want to pause for just a minute and say, okay, this is streaming message-oriented middleware thing. It's important that you understand what it is, but also, why is it such a big deal? Why Kafka? Why do we have all of these industries, these banks, these manufacturing companies? Why are they using Kafka so well, right? First off, it's powerful, right? Our largest deployments of Kafka are handling literally millions of active connections, concurrently active connections to these Kafka brokers, right? It's fast. It performs very well. Again, it's built around this notion of being able to stream large amounts of data very efficiently. And it's also become common enough to be this ubiquitous protocol. So I say it's somewhat standardized, right? Because hey, anybody who knows the Kafka protocol can plug in and start talking Kafka to the rest of the infrastructure that talks Kafka. And I talked about that distributed nature as well. But that also contributes to the durability, right? And so Kafka is even, a design pattern that's emerging now is that people are using Kafka to build microservices, because building microservices, a whole microservices-based architecture around REST, introduced some level of fragile, right? Things had multiple points of failure, right? Because you have all these REST components that are talking to each other. If one of those things doesn't work, then you have transactions failing or things like that. But if you have this message broker as the mediator, it's a lot more reliable on the whole than doing something like HTTP APIs or REST or so on, right? And the example I use there, for instance, is I can start my car from my cell phone, right? The traditional old way of thinking would be, well, hey, you can use a REST API from my phone and you can use a REST API to talk to the car, and the message gets there and tells the car to start, right? But the problem with that is that if the car is in a place where it's, data signal is weak or things like that, you might not be able to talk REST that very moment. Whereas instead, what they do is they have a message bus in the middle. So when I say, hey, I want to start this car, it gets queued up and it gets delivered when the car can get the message. And it might be a couple seconds, but it gets there. And so the use cases for this stuff, it continues to grow all the time, right? And think about it, we're using AI built around Kafka streams, all kinds of monitoring applications, fraud analysis, right? And it makes sense, right? Let's say you're building a fraud analysis software for the banking industry or the insurance industry, right? You could build a solution and you could go to all the different insurance companies or banks and you could say, hey, we'll sell you some consulting hours and we'll figure out how to get your infrastructure talking to our fraud monitoring solution, and kind of one at a time get these companies on board. Or you can say, hey, I built this fraud monitoring solution on Kafka. So you can say anybody who wants to use this, just stream your transactional data or whatever data we're analyzing, stream it to Kafka, and we'll monitor it and we'll do appropriate actions for it, right? That's a much better business model. And so it's become this ubiquitous, very common interface for just homogenizing things, right? So the next reasonable question then is, well, wait, I'm on IBM I and I have this need to interact with Kafka from IBM I, or maybe I'm looking at architecting some new piece of my solution with Kafka because it is so powerful. How do I do it? Right. Don't have time to go into the details today, but if you go to the link on this handout that will be distributed, there is a brief overview of some of the techniques that you can use, including Camel, which I'll talk about in a few minutes. Some of the techniques that you can use to either consume data from Kafka on IBM I or produce data from IBM I, stream out transactional data, and so on. So before I move on to Apache Camel, any questions people would like to ask verbally? I'll stop for just a few seconds.
I don't
Just
see
a few.
any
Yep.
questions in
All
the
right.
chat.
No questions in the chat. And, you know, as I always say, awkward silence means no when we stop for questions. So I will continue on. But again, if you have questions, feel free to ask those in the chat as I go.
Thank
So
you.
I want to talk a little bit about Apache Camel. Some of you may have heard me talk about Apache Camel in the past. It is incredibly powerful, incredibly relevant for anybody doing IBM I activities today, in my opinion. It's a Java-based integration framework, but the important thing is I always say, it can be used to connect anything to anything, relatively easily, by the way. Once, you know, the initial learning curve, you might have to spend an hour or so learning how it works and deploying some of the examples I'll talk about. But you really can connect anything to anything with Apache Camel. And here's a good link in the handout as well if you want to go see some brief information about connecting Camel, connecting IBM I to things with Camel. Right. But how does it work? It works similar to some other technologies. Those who have ever used Node-RED may be familiar with some of the concepts there. So it's very similar in architecture, but it just works by routing these messages through this thing called a route. And so the route has 2 or more endpoints, and each of these endpoints can somehow make decisions, transform the data, add value to the data, and generally they integrate with a thing, and we call those components in Camel. So they might integrate with a certain thing, and those things, they're plentiful. I'll talk about that in a minute. Or again, they might kind of apply something called an enterprise integration pattern, which I'll talk about in a couple minutes as well. Right. So a very simple route with Camel looks like this, which reflects a very common architecture for integration activity, right? You may have a Camel route that consumes data from somewhere, does something with that data, processes it, again, maybe applies some AI, talks to Watson, again, make some decisions, whatever. You might want to log something about what's going on, and then you take that resulting data and you send it somewhere. Maybe it's a file, maybe it's a database, maybe it's an IoT device. We'll talk about that briefly as well. Right? That's what our route typically looks like, at least the simpler ones. Right? What makes Camel so powerful is that there's a ton of components. And anything that for which there's a component in Camel is one of those things that you can connect to from any other thing for which there's a component, right? So there's components for AWS stuff. There's components for certain MongoDB things. There's components for Kafka. There's components for, you know, file systems and IRC. And there's even a component called JT400, which is specifically built to interact with various constructs of IBM I. So if you want to interact with data queues on IBM I, message queues on IBM I, which I say new, it's relatively new. IBM added that last year, perhaps the year before. So you can interact with message queues on IBMI, or you can even call IBMI programs directly from within these Camel routes as well. And so very tight integration with IBMI available in Apache Camel. But that's not the only component that you can use for interacting with IBMI. And there's a handful of others. I mean, there's probably a couple dozen components that you can use to interact with IBMI things. Here's some of the other popular components, right? PAHO you can use to talk to an ActiveMQ broker on IBMI, might be doing some IoT things. You can use the JDBC component to talk to the database on IBMI. There's also an SQL component to talk to DB2 on IBMI. You can execute commands and work with the file system and do all of these great things on IBMI as well. What does it look like when you start programming Camel? We'll see a few examples before I'm done today. But there's a couple major ways that you would typically code up a Camel route. One is to use Java DSL, or domain-specific language, which is really just Java, but they've built it in a way that you can chain together these tasks that Camel does very easily from the Java language. And that's my preferred way to do things. Primarily, I'm very familiar with Java. I find it a lot easier for people just getting started. And it is the most powerful because you can inject your own custom code more easily. If you're familiar with Spring, you can also use a domain-specific language that's built for Spring XML, and you can define Camel routes there. And you see everything here is defined by these URIs, which I'll talk about in a few minutes as well. But a key attribute of Apache Camel is that it makes it easy to apply what we call enterprise integration patterns. Right? And I think there's a few dozen of these that are published by the Apache Software Foundation. These aren't Camel specific things. These are just design patterns that are commonly seen when integrating various pieces of an IT infrastructure. Right? So a very simple example is this thing called a content-based router. And we probably all coded these things up in different flavors without calling them enterprise integration patterns. But we say, hey, here's a new order. That new order is for a green box with these diagonal stripes, right? And that can go to this content-based router, and that then gets routed to the thing that manages either the gadget inventory or the widget inventory, right? So if the order was for an orange diamond with vertical stripes, it would route it over to gadget inventory. Instead, we have a box with the green diagonal stripes, so it goes over to widgets, right? The content-based router, just based on what's in that message, you do different things. Very simple design pattern. There's also this design pattern called a content enricher, where you get a basic message in and you add some value to the message. You add some more data to that message to make it more robust, have more information. This is commonly the integration pattern used for doing AI activity, for example, right? So for instance, if you have a system that's doing automatic language translations, or maybe automatic tone analysis of messages from customers, you're going to take that initial message, you're going to run that through some kind of AI analysis, and then you'll add more metadata to that message that says, yep, this is from a customer who's angry, or this is a French translation and a German translation, whatever you need added onto that message. And we have recipient lists, right, which is like you get a new message in, you need to figure out the right places to send that message. You have scatter gather, which is more for aggregations, right? You need to get different quotes. You need to know different shipping companies and how much each of those companies would cost to ship this, pallet full of lumber or whatever you're shipping around. It's a scatter gather pattern where you might broadcast this request for a quote, and then you gather all the results and you say, hey, here's the most cost efficient option, right? And so those are the almost philosophical design patterns that Camel is built to help you with, right? As you get into Camel development, there are some major IDEs that have all this Camel stuff built in, so you can do more visual diagramming of the routes and things like that. Personally, I recommend getting into the code a little more to understand what it's doing. I really like the Apache Camel extension provided by Red Hat that's available for VS Code. I know many of you are probably already using VS Code for other things. It's quickly becoming the most popular IDE if it's not already in a lot of open source technologies. And there's an Apache Camel extension for that, which I personally find very nice. Now, as you get into doing Apache Camel stuff, again, I talked about the different ways you can code these up. But when you specify all of these endpoints, right? Endpoint for IBMI, endpoint for a database, endpoint for an IoT thing, all of these things are specified with a URI, right? And you probably know what a URI is if you don't just know that a URL is a type of URI, right? And we've all seen these before. Right, the URL starts with a protocol, so HTTP or HTTPS for a web page. You have a location, so google.com in this instance. Then you have a path parameter, which is where am I going in that location, and then you might have 0 or more query parameters. Right, so in a Google search, there's a Q query parameter, and you just put in what you're searching for, and that's what your URL looks like for something like a Google search. Those terms are important to understand because you're doing a lot with URIs when you're doing Camel. And more specifically, when you look at these components and you look at the documentation for these components, that's the terminology they use. They say, yep, here's the format for the URI that you'd use. Here are the path parameters, the query parameters, and so on. Right? And so those key concepts are important to understand. Now, the simplest Camel route that you'd build is 2 endpoints. You're taking information from one thing and you're sending it to another thing, right? And that's as simple as it gets. There's some scaffolding around it just to wire into the framework and things like that. And there's a good link on this handout slide to go start learning about routes as well. But there's actually a lot that you can do with these simple little 2 endpoint routes, right? For instance, here's a message queue to email bridge. So this is monitor a message queue on IBMI and take the contents of that message and send it in an email when a new message pops up. There you go. It's just a couple lines of a Camel route. Might be an eye test for some of you because it's kind of small here. But you just say from a URI that represents a message queue to an SMTP URL, so an email server to send your message. And here I actually introduce yet another EIP, which is a wiretap EIP, which in this very simple example, I just use this for logging, because you want to see that you're actually processing the data perhaps. But you can use wiretap for anything that can be processed asynchronously, because what wiretap does is it takes that message and it sends it off to some other thing, but it doesn't hold up the route. So it's an asynchronous processing. So anything you want to do asynchronously, you can just kind of tap into the route with this thing called a wiretap. And again, the magic of Camel is that Camel will automatically manage a thread pool for you, right? It'll automatically manage the synchronization of that thread pool and the organization of tasks in that thread pool. So it's like, yes, you could build all of this yourself, but you're going to be writing a few different classes, probably 150 lines of Java code to manage a thread pool properly, or you can just say wiretap in one line of a Camel route, and it does it all for you, right? Another simple little 2 endpoint thing is a data queue to Kafka bridge, right? So we're talking about Kafka today. A very common applied use case here is this can be used to stream database transactions in real time to Apache Kafka, because you can now have database triggers that write to a data queue. And so you can be processing those transactions in real time, sending them to something like Apache Kafka, right? Here's another nifty example, consuming IoT data, right? So this is another little 2 endpoint route. You'll see the code in a minute. I have a light and temperature sensor that's hooked up to IBMI. And it's actually consuming light and temperature sensor readings and publishing those readings to a message queue on IBMI. And the code behind it is really, really simple, right? I have 2 different routes. Could have done it in one. If you're familiar with IoT, you can wildcard these, and you could have done this in one. But I have a route that routes things from the PAHO component, which is the component that does IoT stuff really easily, running my IoT broker actually with ActiveMQ on localhost, but I just route the data from the IoT broker with Kafka to the JT400 component, publishing things to my message queue. And so in 2 lines of code, I'm consuming from light and temperature sensors, and I'm publishing to a message queue on IBMI. And so you might say, well, what if you want to go the other way? You can literally like flip the direction of that route and do from a message queue to the IoT device. And now I can actually, we have a light that, again, much more impressive if this were an in-person presentation, but we have a light that's hooked up to IBMI. And I can do a send message command and turn on the light because I just send a message to a message queue and I have that route flip the other way. It sends the message over to the IoT device and the light turns on or off, really simply. So to wrap things up about our Camel conversation, I'll show you a little bit more of a complex example. And it's not overly complex, but it does exercise several of those enterprise integration patterns. And it's yet another example to see what these routes look like once they get more complex, maybe have a little bit of logic embedded in them, right? So this is a simple little disk usage monitor on IBMI. So it just monitors your disk usage. And when your disk usage gets above a certain threshold, in this case 90%, it sends an email about it, right? And it'll send you an email every hour just to be a pain in the butt until you free that space back up, right? So if I'm building a Camel route to do this sort of thing, well, I'm checking on a periodic basis. So there's actually an endpoint that's built just for kicking off this route every however often I want it kicked off. That's just called this timer endpoint. Very common way to start routes. I'm going to use that JDBC component that I mentioned earlier to talk to the database. I can do insert, updates, deletes, all this stuff here. But in this particular example, I'm just going to query this sysdiskstat IBMI service to check how full my disks are, right? So this is the whole code to do all of that. Again, this is maybe a little small, so I'll walk through this in pieces, right? So if you look down at the bottom of the screen, I have it a little bigger for you to pull out the components of this example, right? So again, to start it out, I just use this timer component, and I say, in this case, I'm basically saying, kick this route off every 5 seconds. Realistically, this is very aggressive. If you were on this sample, you might want to turn that down a little bit. I assign an ID to the route, which is completely optional. It just helps if I'm doing any kind of debugging, right? And then, when I read the documentation for the JDBC component, it says the message body should have the SQL that you want to run. And so I just say, okay, I'm actually using the set body EIP, and I'm just saying set the body of the message to this SQL that queries how full my disks are, right? And then we start to see some routing. I'm going to route that to the JDBC component, and a little bit of intricacies here I didn't have time to get into, but I basically have a data source registered called JT400. So I'm going to route this to JDBC to talk to DB2. That component is going to run that query, put the results in the message in this form of a hash map that contains mappings of strings to objects, right? And so I actually have my own little custom Java code that I injected here to translate that. It's actually a message translator EIP. Take that message and just pull out the value that I need. I know my result set has 1 row. I know that 1 row has 1 value. And so all I'm doing here is I'm just saying, okay, take the message, pull out that first value, and set just that first value as the new message as I send it down the route. And so at this point, my message body just has a number in it, which is how full my disks are. which means I can easily start making choices. And this is that content-based router that I showed you earlier in the presentation, right? And so I make a choice and I say, hey, when body disk usage is greater than 90%, do this set of activities that I'll show you in a second. Otherwise, and it just drops down into logging something, right? So it's basically an if statement right down into this camel route, right? Now I want to send an email because my disks are getting full. I don't want to just send an email with a number in it. So again, I can inject my own Java code to say, you know, I want the message to be average utilization of your disks is, and put the number. And then I can route this on to some other places. So I can route it on to log about it. And then I can route it on to my SMTP server to send that email. And, you know, it's as simple as that. And then I can go ahead and pause this thing for an hour. So in an hour, it'll wake up and it will start monitoring again. And again, if in an hour it's still over 90% full, it'll send another email and sleep again. Right? So if you want to deploy your first simple routes with Camel, there is a repository out on GitHub called IBM OSS Examples. Has some really great examples of doing this as well as other things. There's also this Chameleon tool, which I really like. You tell it what components you want to build a solution for, and it kind of builds you this Maven boilerplate that automatically has all the dependencies you need, right? And so if you're just doing standalone Java applications, which is where I recommend you start for sure, you're probably going to be using Apache Maven. And don't have time today to get into details of Maven, but it's really just a build tool for Java stuff, and it does automatically download dependencies and things like that. And again, people might ask, how do I install Camel? Well, you don't install it. You just have a project that says, hey, I require Camel. And then when you build it, Maven will just download it and it'll be ready for you. Right. Some of these examples that are already available for you, you can deploy these today. Although some of them, of course, if you are sending emails, you need an SMTP server. You might need a Slack setup somewhere, right? And that one's actually really cool. So there, we have a message queue to Slack bridge. We use this internally for all of our development systems. I know a few other customers that are now using this, where it will go listen on the system operator message queue. And if there's a message with a severity greater than 45, it'll go post a message to a Slack channel and just say, hey, just so you know, you know, there's a message here on the system operator message queue that you might be interested in knowing, right? A few people are using that already. And if you have Slack, you can start doing that again today. Let me know if you have any problems deploying any of these, right? If you start using Camel and you want to start deploying it, common question is like, how do I run it? How do I have this thing just running and monitoring stuff all the time? There's a few different techniques, of course. I wrote this tool called Service Commander, so I'm a little biased here, but I recommend using Service Commander to start and stop your Camel routes, as well as pretty much anything else that you want to start and stop node programs, Python, Java stuff, whatever. You can register this Camel route with Service Commander, and then it has easy commands to start and stop, and it integrates with Start TCP server as well. So you can do a Start TCP server and TCP server. And Andy Ewens in the chat is giving me an endorsement as well. So thank you, Andy, for that. Andy wrote a really great article on Service Commander in his newsletter as well lately. So if you don't follow Andy's newsletter, you definitely should. Right. With open source stuff, you are never alone. And of course, that's a key point. We have our IBM open source chat on River. If you're doing anything open source on IBM, you really should be in this River chat. If you want to collaborate with the Apache software community, there's a really active forum out on Zulip chat. There's mailing lists as well. You know, Zulip chat is again very, very active. Lots of really good folks out there helping you out, right? Some people kind of get confused sometimes when I say, okay, here's Apache Kafka. It's this message-oriented middleware. It sends messages from one place to another. Then I say, hey, here's Camel. It's this message-oriented middleware. It sends messages from one place to another. And so sometimes people say, well, wait, what's the difference here? And Bruno, yes, Jyoti will be sharing, I believe, a PDF of this presentation today. So thank you. So Camel is really more of an integration framework, as we've been talking, where Kafka is this high-performing distributed message bus, right? The key thing here is that Kafka interfaces with anything that knows Kafka, where Camel interfaces with, barely an exaggeration, anything. But Camel has all this other stuff for doing these integration activities, these enterprise integration patterns, the ability to inject logic and things like that into your route that Kafka doesn't have. And so my really bad analogy sometimes is I say, think of Kafka like a freight train, right? Trains are the most effective way to send tons and tons and tons of stuff across land quickly, right? The most effective way, most fuel efficient. Trains are just good. You can load a train up with so many tons of cargo, and it goes and it gets there and it's reliable, right? Think of that as Kafka, right? But if I order something online, do I expect a train to deliver that to my house? No, of course not. Because guess what? A train can't come to my house because the train doesn't have the plumbing, doesn't have the rail system to my backyard to get to my house, right? And so you think of Camel as this connective tissue. You think of Camel as, the stuff that knows how to load things onto the train, the stuff that knows how to unload things from the train, and the mailman who eventually brings the package to my door, right? So Camel is kind of this connector. And so people sometimes have Kafka as this way to stream large amounts of data. And some of the consumers of Kafka might be little Camel routes that take the data off Kafka and connect it to Slack, or connect it to a database, or connect it to an IoT device, whatever your thing is that you need to connect to, right? And so that's I apologize, I'm not the best at analogies, but that's kind of how I think of it. Is Kafka is this big freight train. You can load tons of stuff on it that are all going to different people, and it's really efficient at what it does. But you need Camel as this way to integrate with all these various other technologies, right? And the next question I often get is, well, can this perform well? And short answer is yes, it can. In fact, when we were starting to build up stories around Power 10 and the embedded AI technologies that you can use in Power 10 now, especially the matrix math assist, the MMA technologies in that Power 10 chip. We wanted to do AI on Power 10. And the way that I architected a solution to be doing this AI with IBM is that I said, well, let's take some kind of real-time transactional data. And what we ended up doing is we ran a fictional stock exchange on IBM. As you can imagine, running tons and tons of transactions. And we stream that in real time out through Apache Kafka using Camel. And we're doing real time analysis of those stock prices and doing real time predictions of future stock prices. And I actually wrote a little blog entry about it. That link will be on the handouts as well. So definitely get those PDFs when they're available, because I have a lot of good links in here. You can read that blog article about why I architected it this way, and the performance is really impressive that you can use Kafka and Camel to just do this stuff in relatively real time to predict things like future stock prices. And obviously, in your industry, you'll have trends and things like that you'll want to make predictions on as well. So that being said, I'll move on to HTTP functions, which is yet another one of my favorite techniques now for integrating open source or other technologies from IBM with the rest of the world. These were announced just last year, I believe August, September, sometime last year. I have a 2-part blog series that I published September last year. Again, really good links in this PDF. Go read this 2-part blog series. It'll go into a little bit more detail, but I'm giving the overall points in this presentation today, right? So the bottom line is that we now have new HTTP functions in DB2. They don't require Java. but they allow you to do HTTP post, get, put, delete, which then therefore allows you to interact with things like REST APIs and do cool stuff. Like this particular SQL example here, I'm doing a qsys2.http post, and that is actually going to send a text message using the Twilio service. I can now send an SMS text message from SQL. And of course, that's the tip of the iceberg, right? And again, you can do post, puts, deletes. There's the verbose flavors, which has extra header information, some utility functions to do decoding and encoding of URLs and things like that. But they don't require Java, which means they're functionally less problematic than their predecessors. Some of you may be familiar with the systools functions like HTTP get clob, for instance, but they also tend to perform better, right? So you can see here we're running in about a third the time using the new HTTP functions. So you can now interact with REST APIs, which is still a very common occurrence in the world of integration, the world of services, hybrid cloud, etc. And you can also use it to integrate with open source stuff on IBM I or elsewhere, right? One common example is somebody had a request to say, I want to do DNS lookup from SQL. I said, okay, well, we don't have an IBM I service at this point in time to do DNS lookup explicitly, but guess what can do it? Node.js can do it very easily. And I won't dig through all the code here, but I just said, hey, I'm going to use Node.js, use the Fastify web framework, and I'm going to stand up a simple little application that uses the built-in DNS support in Node.js to look up the host name that you give me and provide the result. And so what does that look like? Well, in SQL now I can do an HTTP GET. The key point is I'm just talk to localhost. So I stand up my little REST API on localhost using open source, and I just do an HTTP GET to localhost, and boom, I just looked up the IP address for yahoo.com via SQL. And of course, this can now integrate anything that open source can do is now at your fingertips with these qsys2 HTTP functions, right? Even more advanced DNS example, like if you wanted the detailed DNS records to come back, or if you wanted to query a specific DNS server, a little bit more code on the Node.js side, but hey, I can stand up an API to do it. It's called DNS Advanced. And deleted the wrong slide there, but I can stand up a more complex API and do the same thing, do an HTTP GET to localhost, and this will actually give back, I apologize, I accidentally deleted the screenshot, but it'll give back all the records. If you're familiar with DNS, it'll give you back the A, the AAAs, and the NS records, all just because Node.js is fetching that for you, and I call it via this REST API. All right. If you're doing TLS stuff, there's a couple extra steps you need to get those certificates trusted. Won't dig deep into that, but those blog entries I pointed to earlier have more information and pointers. But one last example there is tying things together. I talked a lot earlier about Kafka. Here's yet another way to integrate with Kafka from IBM I. We now have the Confluent Platform Community Edition running on IBM I, or you can run it wherever in your infrastructure you'd like to. And what that Confluent platform does is that it exposes Kafka activities through REST. So in other words, I can send a REST request to post data to a Kafka stream. You can also do consume data from a Kafka stream. And so because I can now just integrate with Kafka using REST, that means now I can talk to Kafka from an SQL statement as well without necessarily using Camel or data queues or anything like that. I can just do an HTTP post to basically my REST Kafka gateway, and it publishes out to a Kafka stream for me. So that being said, there's a ton of other ways to integrate open source stuff with IBMI, or just to integrate IBMI with the rest of the world. The three that I talked about today are, again, Jesse's favorites, right? Kafka. Kafka is just used everywhere. It's high performance, it's ubiquitous, it's streaming, it's reliable, it's distributed. Camel can connect anything to anything. The HTTP functions really help bring a lot of technologies home in terms of REST APIs, especially to integrate with SQL. And therefore, again, you can use this all with embedded SQL and RPG. So those are my three favorite techniques for integration in general. But of course, your needs may vary. There's a lot of different ways to do things, right? And a common approach that's been around since we started doing different integration activities, and of course, data queues even preceded that by a good number of years. We all know that data queues are great for just doing general inter-process communication on IBMI, right? Back in the 1980s, people were using data queues to tie different pieces of their solution together on IBMI, but it's also become a pretty good tool for doing cross-language stuff, cross-system stuff. So, for instance, I can take, some kind of JSON payload, and this is another, I want to send an SMS text message to somebody, but I can take a JSON payload, build it in RPG, and there's a few different ways to do that. Build that JSON payload in RPG, send it to a data queue using that, the send data queue APIs that IBM provides, and then I can consume that from virtually anywhere, right? And especially now we have SQL functions that are able to send and receive from data queues. So if I want to consume that information from a Node.js JavaScript application, I definitely can. You can see here I'm just doing a select message data UTF-8 from that data queue. If I want, I could do the same from Python. I could do the same from virtually anywhere to pull that data off the queue. And this is a good way to tie the worlds together. The downside here is, of course, just the nature of data queues. You have asynchronous processing. Doing two-way communication is doable, but you have to work a little bit just architecturally to make sure you're doing the right thing. Right. And also a reminder that all the major languages, Ruby, PHP, Node.js, Python, R, they all come with some type of IBMI integration. Even Regina Rex, I believe, now works with ODBC to talk to IBMI. But all of these different languages come with some kind of IBMI integration, right? So just be aware of that, because if you're running a Node.js program on IBMI, you're most likely integrating with IBMI from that Node.js application somehow. And we do have toolkits, we do have database connectors to let you talk to the database from these languages. Even if you're running the open source language on a different platform, maybe you're running an application in OpenShift, or you're running an application in Docker, or you're running it on a Linux system. And we have toolkits, we have database connectors that can help you integrate from these other languages as well. So probably not news to a lot of you, but just want to make sure that everybody is aware of that. We have a lot of different libraries available to help connect the dots there. A lesser known tool that I'm actually quite fond of is this this tool created by Scott Clement called Unix Command. This is, again, really great link here. If you get the PDFs, go read the more in-depth blog information about this. But this lets you essentially embed paste commands, which might be a Node.js interpreter, might be a Python command, embed those things in your RPG programs. And it implements this special file so that you can read and write directly to that child job that you're spawning, right? And so as an example of what that looks like, when you go to the project page for Unix Command, it actually has this simple little PHP geocoding example, right? And so what that means is it's a little PHP example where you can feed it an address and it will come back with geocode, lat-long, latitude, longitude coordinates for that address, right? And so you can actually deploy that little PHP program on your system and try this out if you'd like to. But you say, hey, it's pretty simple. You form your command and you can start writing to it. So we're doing a write and a read to this Unix thing, which is this special Unix command, special handler that's injected there. And so you can read and write directly from that child process. So what I'm doing here is I'm spawning a PHP process. I send it in the address of 1600 West Pennsylvania Avenue, Washington, D.C., which is, of course, the U.S. White House. And then I just read the response from PHP, and I have my latitude and longitude. So I really like that. It's a nice tight integration for just calling from RPG into pay stuff. I really like that approach as well. But again, I do want to emphasize a couple things. One, there are more ways to integrate IBM I with the world than I can list here, right? I listed a few of my favorites today. There's tons more. And again, the right answer for you depends on a lot of factors. But the key thing is remain open-minded, right? The biggest trap I see companies falling into is they say, oh, I know how to do it this way, or I know how to do thing X. So if I need to integrate a new technology or satisfy a new business requirement, I'm going to do thing X because that's what I know, right? It's like, well, it's good to know things. It's good to exercise your skills, but it's also good to analyze all of the various options that are available to you. Pick the ones that you think are the best fit, and make sure you're building your solution properly. But again, with open source, you're never alone. I'm always here. The community is here. We also have support available for open source projects on IBM I. So if you want to get support from IBM, this is separate from IBM I SWAMA or software maintenance. You can get support for these things. You go to this ibm.biz/IBMIOSS support. You can get a little bit more information there, but you can get premium support from IBM for ActiveMQ, for Kafka, for Camel, WordPress, all kinds of things. The other thing as well, and this is, you get to the page with all the boring links on it. That's how you know you're at the end of a presentation, right? But there is this new landing page, ibm.biz/IBMIOSS, all lowercase. You can see it right there on the right. That landing page is definitely something you should look at, check out, whether you're brand new to open source or you've been doing open source stuff for a while. You're going to find a little bit of everything there. You're just going to initially see a bunch of links, but there's documentation in there on how to do a lot of stuff with open source, from how do I install open source on my system, how do I set up a user so that all these cool Unixy commands are available, that their environment's set up properly, how do I use various technologies like Nginx and Python and Node. So there's some really good documentation out there. Most importantly, there's links to community channels. We have the River chat that I had mentioned earlier, probably the most active. I think we're over 800 members now. Anybody doing open source on IBM I should be part of that chat. There's also the IBM I community on Slack. There's an open source thread on Midrange for those familiar. But there's plenty of the community channels are documented out there. There's also links to some really good videos and blogs. I think there's even some links to like Andy Ewan, since he's attending today. He's done some really great video tutorials. I think some of those are linked out there as well. So just a lot of good resources to help you along your journey if you're doing anything related to open source on I. But the key point, again, is that you're not alone, right? The biggest folly I've seen IT professionals make when it comes to doing open source on IBM I or elsewhere is that they struggle. Like if you run into problems, I've seen people who have run into a problem and they've struggled for 2 weeks, 3 weeks trying to figure out what they're doing wrong, and they've not bothered to ask the community anything. They've not bothered to raise a question on a GitHub repository or join a chat somewhere. with open source, you're never alone. If you're having issues, reach out and we'll do the best we can as a community to help you out. So that's a real key takeaway today as well. So with that, I don't see any more questions in the chat. I'll stop in a minute to see if there's an awkward silence or anybody has verbal questions. But again, just to summarize, my favorite techniques for integrating IBM I with the world are Kafka, Camel, those new HTTP functions, but there's plenty of options for you. So with that, any questions from the folks attending today?
Thank you very much, Jesse. Oh, gosh, quite a lot you've run through there. Lots and lots of useful information and lots of links in the PDF, which I will be sharing later today, hopefully. No questions coming up in the chat that I can see, unless you've got something directly to yourself. Oh, there is one question that's just come up from Alan. What is IBM's position on the recent news about protestware and how can that affect us?
So I'm going to play conservative as probably expected here and say, I can't speak for IBM. I can't provide IBM's position on anything. I would say that's above my pay grade. But whenever there's questions in this realm, there's a couple things that I just want to point out. There's a lot of governance and there's a lot of processes with key open source projects in the community to guarantee the stability and usability of the packages, right? And so what that means is if you're taking a sane approach to managing what releases you're running, you will protect yourself from a lot of the volatility out there. Because you're not the only one with skin in the game using these open source packages, right? There's a lot of hype and buzz in the news sometimes to make things seem really, really bad. But in reality, you are using the same technology, generally speaking, that, Fortune 100, Fortune 500 companies are using to build their solutions, host their websites, build their APIs, build their streaming messaging infrastructure, and so on. It's the short answer is I would say don't worry too much about things like this, but again, I can't comment on IBM's position for any of those things. But thanks for the question. Good question.
Thank you. I don't see any more, so let me just wrap it up there for today. Thanks again to Jesse for coming back on PowerVug and telling us so much more about open source on IBM I. We look forward to having him in future sessions if he agrees, if he's not fed up of me already.
Absolutely not.
Thank you. And thank you to everyone who's joined today. Really appreciate the time that you take to support PowerVug and join. So appreciate that. I hope to see some of you at some of the events that I mentioned, and watch out for the next PowerVug session. I haven't yet got that on the PowerVug info page, and I'm in the process of setting some sessions up. So just watch this space, as it were. So once again, thank you so much. I'm going to stop the recording then.